Okay, good evening, everybody. So let us start. Let me share my screen. Yeah, are you able to see my screen?
Yes, Professor.
Yes, Professor.
Yeah. Okay. So we'll take the next step. So till about last classes, we studied about when we have one equation, quadratic, polynomial, all those fancy things and all came up as the problem required that kind of equation. Now we move to system of linearity. So this is how a data looks. In fact, like for example, so equation whatever we see on this currently I have something. So it shows that some 2x plus y is equal to 32 and x plus 3y is equal to 36. So these are system of equations. So for some problem it has been stated. I think we had solved something like this in our probably high school or something around +2 or something like that. So we had this kind of things in our mathematics classes. So this is what we do. So how to connect dot with statistics. So this is the kind of data you can expect. Like when I say x, y, and all. So I have been using x and y for our equation. So for each x, y, what is the context of the data, how it is, and all. So this becomes like a structure for us. Like for example, I have a matrix kind of a structure. So till now I had some kind of a vector kind of a so now matrix. So if I say data, for example, so I think we plotted something having x and y or something like that. So if we have large data sets and allow how to analyze the data, so what is there inside the data, so how we have to analyze it. So we take a step next, like where we will solve some systems of linear equations. So that is very much important. So when we have the systems of linear equations, how we solve it is what which we will attempt today. So yeah. So I have some kind of matrices with me. So how to solve that thing is what which we will try to do. So in the process, we learn matrix algebra also, and how to solve it in using Excel is what we will try to do. So it will take time for me to like put these things and all. So by seeing this thing, you also start putting data onto your Excel so that we can solve this thing. So we'll do what is known as matrix addition and subtraction. So I have 3 matrices now. Let's try to do. Okay, let me open my Excel. So this is my A matrix. So B matrix is F. B matrix is my G. -5.3 -3 -4.5 0 2 to 0.5 0.17. So I leave a space in between and put the other one. 1.3 minus 12.7 082 4 minus 1 T will be 1050. I don't know why he has taken like that. Okay. C for 1050. That is repeated. So I have my three matrices there. So if you see, hope you also have put those things as necessary. Okay. So I want to have an answer for this thing. So what exactly we need to do? We'll do some addition of this thing, matrices. So three matrices. So what it will yield me is what which we try want to get it. So I'll put the thing here. See how you have to put it. So it's not so easy like you just add those things at all. So you should be using a command. Together we have to press it and do it. It is known as Control Shift and Enter. So first I need to, I don't know, it doesn't do a copy paste for me. That's one more problematic. So is equal to A2 to C4 plus E2 G4 minus I2 colon K4. A control. So I'll paste this in this thing. Hope you can also copy paste. So M2 to O4 is what I let me move this way a bit. So this is the resultant matrix which I have it. So I highlight it, paste it here. So I will use it completely now. Control, Shift and Enter. So together I'll press and put it. So I get the answer of this resultant matrix. So all got the answers. So I highlighted, then went to this function, this thing, pasted whatever was necessary, and I did my cursor was somewhere here. Then I pressed Control, Shift, and Enter together. That's it. All of you got the answer. Yes, I'm not hearing any answers. Anybody successful getting this answer?
No, it's showing error.
So you did the way as I told you.
Yeah. ABC. So this is it.
Can you just show that last step again?
The only thing you have to do is that first highlight this thing and whatever I shared on the chat, this thing, pasted it here. I didn't press enter immediately. I pressed Control, Shift, and Enter together. So first I had my Control thing pressed, then Shift, then Enter. So this is what I did it, and I got the answer for everybody. So 3 matrices I was able to add.
Seriously.
So anybody else successful? You can press put any numbers actually. Just put by a 3 by 3 matrices. That's all. So
Got it.
3 into 3 matrix. That's all. So you add this thing and you get it. Okay. So next will be so I put minus directly. So I did a matrix subtraction also. So if I put plus here, you get the answer for the addition. Let me also show that thing. So I did this thing. So took this thing again. I am showing you. So let me come here. Let me select something else here. Go to the screen here, the function space. So paste it here. Then I say Control, Shift, and Enter. This addition of 3 matrices. The first answer was first and second matrices were added, and it was subtracted. The third got subtracted from the addition. So it's a different answer here. So if you see on the screen here, so you will get a different. So minus 3.4, minus 14 and all. This was the thing for the first one. I just replaced this thing by 1 plus but different answer. That's all.
Actually, only this query we can use or anything other you did because it's not working. Some error is doing value error.
No, this is all you can do it. That's all. See, I'm choosing what. So just concentrate on what I'm telling. So I'm choosing A2 to A4 here. Sorry, C4. So what is that A2 to C4? Let us see that. So this is one matrix.
Okay.
So E2 to G4 is one matrix. I2 to K4 is one more matrix. That's all. So what happens is like when you multiply or add or something like that, so it is always R into C. That is the notion. R means row, C means column. So all columns. So whatever. So in this thing, 3 is the column here, row is this thing. So next matrix also is 3 by 3. So the column number should match with the row number of the second one. So that's how the matrix functions and all work actually. So that you have to be very careful with that thing. That's all. And you have to will get an answer. So anybody else could do it successful? Any challenges? Anybody? I don't know. I'm not hearing anything today. Hope you are all trying with me or okay, I assume that you have done it. So let me move to the next portion. So we'll do a scalar and matrix multiplication, we'll use Excel to do what we need to do here. So what I need to have, let me take it here. So I have some numbers here, 44 to minus 8. -44, 2 and minus 0.3, 7, sorry, 0, 17. So I'm multiplying something like 3 multiplied by this matrix. So using a scalar quantity means a single number. As you all know, I'm trying to multiply that thing. So what it yields me is what which I need to see. So I need to get this thing right. So is equal to is equal to 3 multiplied by not A2 to C. I think it's somewhere different here. Where I have put it. So this is A6 to C7. So C7 is where I have it. So here also I need to so answer will come something like this. Again, a matrix structure. So this is a 2 by 3 matrix. So I need to highlight that structure here. So I'll put it here, 2 by 3 here. Go to this function cell, paste whatever I have. So this is ready now. Here also Control Shift and Enter I press. So I get this answer. So am I right in getting the answer? Yes, this is the answer which I have got it. So it will what will do? It will do 44 into 3, 2 into 3, minus 8 into 3. It will go on doing it. So that's the way it will try to multiply, give the answer. So what we are doing in our classes and all during our high school days and all, you can do it in. So this is the structure, the data structure, like as needed for statistics, how we do manipulations and all, is what which we try to understand. So product of two matrices. So please see it here. So for the first matrix is a 4 by 3 matrix. Notice second one is a 3 by 3. So that's what I told you. What things should match. So have 4 into 3. The other matrix is 3 into 3. So this 3 and this 3 should match. My resultant matrix will be 4 cross 3. So I think this you know probably. I will not emphasize on that thing. So I'm trying to do a matrix multiplication here on two matrices. Let's see what we get as an answer. Okay, let me put it here. So okay, I'll be putting it here. That should be fine. So my matrix is 5.3 minus 3 minus 3 minus 4.5 0 to 0.5 017 666. So this is a 4 by 3 matrix. Now I'll put a 3 by 3 matrix here. 2 0 minus 1 0, 2, 2.2. Sorry, 0.2. 8, 0, 17. So I should get the resultant matrix here. So my so I'll use a inbuilt function for matrix multiplication. Only if you have correctly, then only it will give an answer. So you have to select what exactly it will give, then only you will get an answer. If you have wrong matrices, then error will pop up. So I will use m multiply here. Equal to m mult. Where is my so A9 C12. So I'm not using any what you call star sign or multiplication sign. I'm using a comma here. So please note that thing. So a comma is put here. So this is from E9 to G11. As I told you, the resultant matrix is 4 by 3. So 1, 2, 3, 4, 1, 2, 3. So this is my resultant matrix. I paste it here and I say Control Shift and Enter. So this is the answer which I get for matrix multiplication. So who were successful?
Yeah, was able to do it, Professor.
Okay, good. Okay, then we'll move to inverse of a matrix. So I have a matrix. So we'll take that thing and I have my inbuilt this thing and I get the M inverse of a matrix. Two, 0, minus 1. 0, 2, 0.2. 8, 0, 17. Sorry. So this starts from A14 to A16. So highlight this cells, paste it here, Control Shift and get the inverse of a matrix. So all the theory and all is given in this book. So interested people can look into this thing. So how it does, what we do and all is completely given here. You can look into this. Okay, that was about inverse. Now determinant of a matrix. So it is 2, 0, minus 1. That's 1. 0, 2, 0.2, 8, 0, 17. So this is from A18 to T20. So this I need to just change it to M deter. Then go here, paste whatever is there, press enter. There's no control shift enter. The determinant of this matrix is 84. So only here, not use control shift enter, we'll just get the determinant of a matrix. So solving system using matrices, that's what we'll try to do it. I think that's a whole thing which I have it. So let's see how best I can do it. So I have some coefficients, the constants, the inverse, the solution. So I need to find the values of x1, x2, x3, x4, and x5. That's what we try to do it using this matrix multiplication. So the first one will be coefficient. 1, 2, minus 3, 1, 2, minus 3, 2, and minus 2, 2, 3, minus 1, 3, minus 1, 3, 1, 3, 1, minus 4, 3, minus 1, 1, minus 2, 3, minus 4, 2, 0, 0, 4, minus 5. So coefficients means whatever is there, as you see. The last equation we have only for x1, x2 and x3 is not there, so 0 is there for that equation. Rest and all coefficients as defined there has been taken in as part of the coefficients. Leave a gap and put constants. Minus 6, 22, 0, 0, minus 7. So I need to find the values of x1, x2, x3, x4, x5. So we did single equations, we solved it. How to get that thing also, we calculated that value. We use solver also to do it, that kind of a thing. But solver required some other inputs, like you have an input, output, and a decision variable here. Here using the matrix knowledge, whatever we have done just about a few minutes ago, try to put that thing and try to find the solution. So A9 to E13. So I should put there A9 to E13. What is the thing which I need to take it? Equals M inverse A2 to E6. I'm calculating the inverse of the coefficient matrix here. Come here to the function space, paste this thing. No, no, and this, I don't know what happened. Now press Control Shift and Enter. So get the inverse of the coefficient matrix. So we should get a solution for this thing now. If you multiply the inverse matrix by the constant matrix, the result will be the solution matrix. So that's what we will get it. So highlight cells G9 to G13. Okay. M mult A9 to E13, comma G2 G6. So those two, one is a column vector, other is a matrix here. So I'll try to multiply it, press enter here, Control Shift and enter. There is something wrong here. So what has happened? I'm wrong, or I don't know. Let me check.
The formula, Professor. M mult.
M mult, right? Okay, right, perfectly. Thank you. Control Shift and Enter. So you get the solution as 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, and this is xy. So what is this meaning? So if I put in the first equation, if I put 1 into x1 is 1. So this multiplied by 1, what sign I have? Plus sign. Then 2 multiplied by 2, and I have a minus sign. So 3 multiplied by minus 3. Then I have a plus sign. 4 multiplied by 2. Then I have a minus sign. 5 multiplied by minus 2. So press enter. So it is 32. Where am I wrong? I should get minus 6. I have done something wrong here. Yeah, can somebody help? I should not get 32. I should get minus 6. Right? Using the RHS and the coefficients, I have got the values for x1, x2, and xy. If I put those things, I should get minus 6. Correct? Can somebody correct me here? Right, that's what I need to get. Correct? So when we see the formula, if I say F2, yeah, whatever coefficients is there, I have taken it.
Professor, can you remove the minus G11 into C2 and G13 into E2 and see what is the value, and then do the G11 and G13 and see what's the value, and see if you minus both, you get 6.
Can you please repeat it?
Do the additions of all the, wherever it says add, just add them separately. Wherever it says subtract, subtract them separately, and then see if it sums up to the value 6.
Okay.
This is just trying to see if you can get the value 6. You can copy the same.
Okay, so what I need to do, I should take that.
Yeah, which says G9 into A2 plus G10 into B2. Then do plus G12 into D2. Do this as 1. And then you do G11 into C2. and then G13 into E2 as addition. See what value you get, and then you subtract the first one from the second one.
Okay, let me try that out. Oh, I get 13. Hmm. Yes.
So now if you subtract 13 and 19, you get 6.
Yeah. Thank you.
Yeah.
What is the logic here? So
The reason is when you were doing that multiplication of the subtraction, right? It was minus into minus. So it is becoming plus.
okay, fine.
Yeah.
So or I need to add a bracket or something like that here.
Yeah, what you need to do is in that C2, right? If you just see if you can add minus C2. I don't know that into C2 you've written, right? See if you can add a minus and see if it works. I'm not sure, Professor, but I know if you split it and work, it works. So
Yeah, good. Let's see what it.
yeah.
So then
E2 also will become minus E2.
So then I make all the things addition here, right?
No, leave it. No. Just press enter and see, Professor, if it works. Yeah.
Yes, it works. Yeah.
Yeah.
Yeah. So each one of the probably my bracket I should have put, but good thinking. Yes, this is what we require.
Sure, Professor.
Yeah, thank you. Thanks a lot. So this is what which we require. So why we need to find out this thing and all, as I told you, like as we move to statistics and all, like what are those things like unknowns or something like that. We create a model. Yesterday in Monday's class, I spoke about some model and all. So I spoke about linear regression and all. So based on the data, it created a model for us. So if I input something for a future, it will give an answer. So first we will try because it will give for me two things. Right? From the model, you can recreate the observed variables also, and it will also predict for me. So difference between observed and predicted is the error which is important for us. So as we learn the foundations and all, when we move to statistics, what we do. So we do some inference and all, everything we can. So as you come to linear regression, the concept about why I did all this set right in your mind so that you start playing a lot with the kind of numbers which you have, the tools which you have learned, the techniques which you can apply here, all these things which will come there. Of course, if you think everything as a black box and up to do also, that's also, but good to know at some level. So that is what is very much important. Okay, good thinking. Yes. So that was about solving a system of linear equations. So any questions you have? Okay, so I don't have any questions. So let me move to the next aspect of linear programming. So this will be a part of prescriptive analytics, which we taught. So, but nevertheless, we are continuing with our way of mapping inequality or something like that, or we always did equal kind of a thing. So everything was y is equal to something, or we tried less than or greater than or something like that. So this kind of hypothesis also kind of situation will come in hypothesis. Try to learn a bit of statistics. So conceptually, like how it happens, how we should understand what is meaning of less than. So mathematically, we understand our space, like so you all were taught mathematics in the Euclidean space. So how we can map it and all. Because conceptually, you have to understand sitting in front of a computer, trying to model whatever the things is very much essential. As a continuity of this thing, a little bit on this I will cover, so that you will also have a fair idea about how to, when you touch base with the prescriptive analytics of business analytics, you will find this interesting. So this is about graphing in inequality. So all these things were very linear. That's why it was system of linear equations. So all were equal to equal to. Of course, we had negative and signs and all. That's all fine. Of course, we studied a polynomial curve also a quadratic curve also. But for that thing also, it was all, everything was equal. So it's a linear situation as such. But when I have an inequality, what we should. So to graph inequality, y greater than or equal to 2x minus 5. In Excel, we need to plot the line y is equal to 2x minus 5. Enter values minus 4 or something like that. Let's try to do it. Highlight it and let's do the next thing. What exactly we mean to say that graphing in inequality and try to understand the concept behind this. And this is a part of linear programming in today's world. So some years back, or say at least about 2 or 3 years back, these are all taught, especially some engineers are there who have studied mechanical. They have had a course on operations research. Anybody mechanical engineers class? Nobody? Okay, not a problem. So they would have learned this thing as part of a paper known as operations research, where all these things would have been taught to them. Of course, they might not have used software or something like that. They would have just used a paper and pen and might be a calculator to get the answers. That's all. Let's try to put it in the form. Like now we are trying with the inequality. So either it can be greater than or equal to, or less than or equal to, less than or whatever it is. So this is a situation, as the author had put it, is for y is greater than or equal to 2x minus. So how do you imagine this thing, like when you get this kind of situation? What with regression also, when we try to interpret a regression equation, we also see something similar to this. For that one-to-one understanding, we need to know it from a mathematical standpoint. So let's try to do it. So what I need to put again x and y. Okay, up to 10. I should get it. Okay, A2 to A15. Okay, let's see. Come to my Excel workbook. Tab. So this is my x, this is my y. Okay, minus 5 minus 4. Am I right, or still what he wants? A2 to A15. Enter the formula 2 multiplied by A2 minus 5. That's what we need to do it. Minus that is 2 multiplied by A2 minus 5. So minus 15. Okay. So this is the answer which is for y. A2 to B15, highlighting. Go to insert. Which one I need to choose? Last. So this is the chart which I get it. I think this we used to do, probably draw in our classes, high school classes or something. We used to share and all. So something similar. How it can be done through Excel is what which we are seeing, and related to regression or prescriptive analysis is what which we see. Okay, this is inserted. Shading the half page is done free from a free form graphic tool from shapes found as, I don't know where to do that. So what I should highlight, where I should highlight. What I need to choose. I'm saying something, but you people also try it out, like what needs to be done. Now I have the graph. Now I go to insert. Yes. Need to choose this one. Okay. What do what?
You click on format shape, Professor.
Okay. Now only I do it. Okay. I have not selected it. Okay. Will it allow me? Okay, it is allowing me. Then I go.
There is
Yeah.
a text file that you can choose. Save fields, save outlines. You can choose.
Okay, save fill and need to choose a blue or something like that.
Yeah, you can. That is the whole. But if you want to choose,
Professor, I think that text effect, it has, after the text effect, there's a small icon. Next to that AA format that you see. If you come out, next to that AAA, then you see text fill, text outline, text effects, and at the bottom there is a small arrow. Yeah, just click on that, and if you could go back to the screen, I think it's based on this what they asked us to fill.
Okay. So if anybody is getting on their shape styles, I have to click it. Okay, let me do it. Okay, it opened this thing for me. Fine. Now what to do? I don't know. Okay, let me try it out. What it comes in. Chat opened. What? But I have this plus thing open, so it has to fill that thing. I don't know. It's not. So some half-baked knowledge is not given things properly. I clicked on it. It's a format. Okay, I clicked on shape style. Okay, I think Shape style also I should take it. Okay, let me see. Okay. Hmm. Now press on this thing. Now what I should do? I don't know, that's a mystery. No. Okay, let me see what. Okay, I got this thing, but it is wrong. But what exactly I need to do? I don't know, you got this thing right. Okay, choose whatever I have chosen, that's fine. Then blue thing you choose. Change the transparency of the shape in the new menu. It will appear to the right. Okay, transparency of the menu. Okay. So,
Professor, if you can remove the fill, so it works. It is just that you have once you click on the shape, right? When you say insert, click on insert, and then click on the shapes, and then click on that. Yeah, and then what is you draw that line in the chart, right? In the chart title, the top portion that you have, you can just select the top portion. Yeah, like you have to literally draw a line and then come down and then cross an entire section. Yeah, and then go top. Once you do this, click on format. Yeah, that's it. You already got it. I'm so sorry that even for me it came the same way, but then I thought this is the only way that I could get the.
okay, yeah,
fill.
I'm not good at customizing. Okay, now go to format shape and do what? Like
You want to fill the color. You can change the color of the filling to any color that you want. That you can also do it in the top bar where you see shape fill, right?
okay, let me do some fancy color. Okay. Yes.
Yeah, Professor.
Okay. Okay. I don't know. Somehow I got it, but it's wrong. What near to whatever he has done. Okay. So graph of the inequalities y is greater than or equal to 2x minus 5 is this. So how to interpret it now? So are we right in interpreting this thing? Because shading thing is done. So like to understand for our situation, so we drew a line for we calculated a y for different values of x here, 2x minus 5. So greater than or equal to this thing is above that line. So would you all agree to whatever he has drawn? So this is just graphing the inequality, like where exactly that 2x minus 5 lies is what we have to find it out. So everybody agrees to this thing. The shaded area is the place where all the values of y will lie, given values for x, which is the equation of 2x minus 5. Yes, people can give their own arguments here. Yes, no, or how is it, like how we should understand and all. Because now it is something like interpretation is with the analyst. An analyst is myself, yourself. Those are the people who have to really in front of a client is what which we have to say. Because all we get is some numbers and all, and we have to talk about that numbers in certain way. So this is a freehand tool we have used. Of course, we calculated whatever is required. Shaded area, what it says is that the graph of the inequalities, it falls. That blue area is the thing. Would you all agree that all the y values fall there or something like that?
Professor, does it mean that anything above that exponential line is inequality, and anything below is like,
So anything above is greater than or equal to 2x minus 5. I mean to say all the y values will fall whenever the x values changes in the right hand side. So that's the shaded area where you get all the answers. So that's the thing with it.
okay, Professor, if you have to use this, where exactly would you use it in a real life scenario? Like,
Yeah, it's in linear programming. So we
Okay.
did that solver and all, right? So
correct.
in solver, we used a input variable, we used the output variable. By changing the decision variable, we got it. So this is some kind of scenarios, like you have some greenfield projects and all coming and all. At that point of time, we have to use this kind of deterministic models. So any analysis is mix of deterministic and stochastic. Of course, our end goal is like statistics, what we learn in, but it's a mix of everything. Like, so how and why kind of tools which you use, we have to think about it and put it. So this is how we try to put it. So it will be very good for prescriptive analysis. Prescriptive is like something you prescribe to a client, so or to your manager or to a team. So that's how you have modeled. So these are the some things. So what is X, what is Y and all. So it depends on, like, for example, it might be something like finding oil or finding gold or something, like there is some lacuna in a system, you have data for that kind of a thing. So in a boundary space, wherever it is, this is the area where you find that problem. So this is how we try to say about it. That's when these things become helpful. Would that give an answer to you, or you have still doubts in mind?
No, Professor. Maybe I think I'll just go through a little
Yes.
bit more and then come back.
And you can, yes, please, definitely. I would welcome that. I think have some that linear equality.
Yeah, Professor.
So he says that, like, so what is that thing? A line divides the plane into two regions. A vertical line divides left and right. So in either case, dividing the line is called the boundary line of the each half plane, as indicated. So upper half plane is up. So it's greater than or equal to means like whatever falls there, the answers are there. Something like that, if you have to see. So understand this thing like through an equation, what he has also provided. So you might understand what I mean by it. So immediately you may not connect to whatever I am saying, but this understanding is quite necessary when we move to the scenario of solving the problem. So why, how, why it comes there, and maybe not to whatever examples I may really give it, but if you move higher up in terms of the data size, or if it is like a polynomial or a quadratic kind of a thing, at that point of time, it becomes very much important to understand, because a software or some program or an analysis might only give this thing. Of course, using a programming this thing, it can shade for you and give it. So that capability is there. Here, that capability is not there, but we are trying to put that thing in a form that using some freehand tool will fall there. And it follows the whatever the person's answer he has given and all is given here. So when you see this thing, if it is greater than this thing, x minus 2, the region is here. So x greater than or equal to x minus 2 also, the region becomes something here. And you can see the points and all where he has mapped and all. So if it is less than x minus 2 means it is below this line. So now we have to understand this. So on a graphing calculator and all, you get this kind of thing. So that is quite possible. Excel will not give it, but it is quite possible in any other programming language and all if you use it. But conceptually, we should understand it, why, how, and all it comes. So that thing should be clear. There should be no doubts. That's all. Okay, you please go through this book once more. If you have any doubts, feel free to contact me. Okay.
Sure, Professor.
Yeah. So this is what which we got. So this is for that y is greater than or equal to 2x minus 5. we'll have, there is one more thing given here. So you can please do this exercise, see what it comes and you can interpret. So same thing, he uses formatting and all, where and all it comes. And here remember, it is not one equation, it is a system of equations. So two equations are given. One is greater than or equal to minus 2x plus 1. Other is y is greater than 3 by 2 x minus 1. So where exactly it lies? So you get two lines. I have 1x, 2 y's actually. One will be 1y1, other will be 1y2. So you plot it. So as he says that how to plot it and all, these are the things which we get it. So if you have this understanding, we'll move, because we have already understood how to use a solver and all. So we'll move to the next aspect of the linear programming. So we'll solve the following linear. So I need to maximize something. So maximization is profit. So minimization means something to cut it down. So for example, workforce, there are about 1,000 people working on a project. I may not require that much of a people. I need to cut it down, means that's a minimization problem. Maximizing is profit maximization, like sales. Sales in a particular territory should increase by something. Subject to what? So you have to solve so many system of equations here. So if you have that kind of equation, you'll get it. Let me just give a brief thing like here. Examples are good. So for example, you have something with regard to production scheduling. So how exactly we put that equations and all, how it is transferred to a model. So first one is the objective function, second one are problem constraints, third one is the non-negativity constraint. So everything should be, we can have to have a negative. Of course, we have non-linear situations, but that's not part of this very basic process at all. Even in a if somebody does business analytics and all, that may not be thought there. So it is for fully mathematical problem solving. So where we get a minus things also is possible. So many Indians under 40 have won what you call, there is no what you call Nobel Prize in mathematics actually. But a Nobel Prize kind of a thing is given to mathematicians who are under 40, and that is known as the Fields Gold Medal. So many people have won in this kind of, many Indians also. As I know, at least about 30 years back, one person known as Narendra Karmarkar, working with Bell Labs in US. So he was the first person to win that Fields Gold Medal of solving this non-linear kind of a thing. And his problem was about airline seating problem. So I don't know, like if you have traveled by Indigo has a particular layout. If you travel by Vistara, you have a particular layout. So if you travel by Airbus 320, seating layout will be there. So A320 here in Indigo, it will be different from A320 of Vistara. So anybody has noticed that seat changes? I think all of you might have traveled by air and you might have seen that seat thing. So you have a business class, you have a premium economy, then economy. Anybody has noticed that?
But actually, seat or linear or here means I didn't get actually. Seat, way of seat is changed because of
Yes.
linear.
So usually seat A320 flights have 3-3 seating. But how much a airline should fill up the seats based on the like the time of departure and all. So that is a problem of profit maximization per flight or something like that. So in that thing, like you have different things. So business class, if you notice, the first 4 these things or something like that in the A320 flight will be 2+2, and you have a curtain separating or something like that. I think Indigo doesn't have, only 2 lines of thing are with business class, rest are with 3+3 sitting. Vistara has 2 plus 2 this thing for a business class, and you have a premium economy which will use 3 plus 3, but distance between the seats will be more. So that kind of a thing. So these are all some constraints we put on this thing. We try to achieve this thing. Of course, based on the thing, they make money. So what I'm trying to say is like how a problem of a airline sitting seats, whatever we see on the thing, can be solved using this kind of a situation.
Yes.
Hope I
Okay.
was able to answer your question.
Yeah. But how they put the area, then they X and Y, and how the seat they will do, they decide like
So
that.
for example, Air A320 is manufactured by Airbus Industrie France. So when somebody now, for example, Air India wants to order new A320 flights, so it will go and tell that see, it will have its own business plan, for example. So everything is a business at the end of it. So it's a management problem. They will say that I like to have this kind of seat layouts and all, so that I will like to. So they might say that I might have a first class business. So first class business means the first one will be 1+1 kind of a thing. So I don't know who will travel, and all might be all corporate people like CEO of Airtel or something like that might travel, but they have their own aircrafts. What I'm trying to tell you, those are the people who can afford. See, for me, going from Bangalore to Delhi will be charging about, say, roughly I'm saying, approximate will be 4.5 to 5,000. But that seat may cost about 25,000. Both are on the same flight, but he will have that kind of luxury. And the airline also will go by the aspect of how it will make money. See, by default, Airbus will make only 3+3 seating. So they will have to remove that 3+3 sitting and accommodate this 1+1 kind of a sitting. For them, it's like customization. They will do it for Air India and give it up. But how Air India will make money is very much important. So that's a business situation. Correct?
Okay, that design the mechanical people decide using the linear programming, or graphically. Okay.
Yes. So that's how, this is one example. So production scheduling, all these things we can use it. So you can think of anything. There are many things here mentioned here. All lots of problems. It is not respect to whatever thing is applied in agriculture, it is applied in business, it is applied in economics. In economics, what we do is like game theory. So today, I think if you are reading news or something like that, so there is a Russian-Ukrainian war is happening. So what is being planned? Military strategy is being planned using game theory, which is part of this descriptive analytics. So they plan like military strategists are all mostly, they know maths, they know they would have actually fought in wars and all. They try to put this mathematically and all. So they will give strategies to actual people. So they will advise people, advise somebody from the Ukrainian president how war should move and all. So that is known as game theory. Maybe after this class, we search for game theory and all. So how that mathematical strategies and all. A game theory problem can be converted to a linear programming problem. All this things can be done. Just read it out. It's a very good thing. So like this, lots and lots of business problems are solved. Okay, now we will solve the following linear problem. So that is maximize has something subject to so and so constraints and all. Let's see what exactly we'll find out about from this. So objective, it work with me. Let's see what it comes. So what cell he has put A2 is objective. So this is Z here. 8 multiplied by D10 should I put this or okay, put it equal to 8 multiplied by B10 plus 12 multiplied by B11. If I put this, error will come in. Okay, now 0, fine. Good. So I should get values for that thing. So I got two constraints, first and second. So this is in P5. First, second. So this is 40 multiplied by, from the equation only I am taking. So this is 80. Is 6 multiplied by B10, 8 multiplied by B11. Multiplied by 8 multiplied by, that is also 0. Why? Where was I? Okay. Decision is 9. So I have an X, I have an Y. And 0, this is 0. Now I'll use solver and see what I have to put for all this. So my equation is this one. So LHS I have put. I need to put this 560, 72 and all. So X is greater than or equal to 0, Y is greater than or equal to 0. That's how I. So this is a very raw way of putting, but nevertheless, no problem in this thing. We try to go by this thing, like let's select solver, analysis tools, make okay, set objective B3. Data solver. Okay, objective is B3. So maximization problem. So B10 and B11 is what I need to change. Okay, so this is a maximization by changing B10 and B11. I got it. Now I have to add. So how to add that thing? What we have to find it out. B6 is less than or equal to 560. I press add here. So cell reference B6. So I have all the things. I have less than or equal to, greater than or equal to, and other things and all is there. By default, I want to select less than or equal to. So what is my constraint here? So it was 560. And I will say add here. So because when we see this, when I say okay, you'll notice that all the other things are also have been added to this. Next one is B7 less than or equal to. B7 less than or equal to 72. So if I say okay, notice this, both the constraints have been added to this. So make unconstrained variables non-negative. By default, it will be there perfectly right. And I say, I should get the answer as, what is my profit? 100 should come here. So that is the objective I want to achieve. First constraint 560, 72. So decision variables, it varies. So okay, so 8 and 3 will come. So this is the internal calculation it will do. Draw out the result. Let's see if we will get the same result. So when I say solve, yes, I got it. So this is how we try to solve. So x and y should be given 8 and 3 numbers. Constraint was this 560 and 72. Objective. So this is a profit maximization. So 100 is the profit. Based on the context, that's all that is much important. So this is how we try to do a linear program. There are many examples here. Probably you can put it on your own Excel sheets and try to something like this. What it comes and how all those things can be done. Okay, what I had for today. Any questions you people have, I will be happy to answer. Any questions? Okay, I don't have any questions. So let me stop here. So next class on Friday. So we'll start with probability. So there will be theory. I think PPT has already been shared to you. We have some things which we can work on. Then we can start with our statistics. So is that okay?
Yeah, Professor, thank you.
Yeah. Okay then, thank you. Thanks for joining.
Thanks,
Sir, this is
Professor.
Deva. Sir, I'll be sending the file to you shortly.
Yeah, no problem. I received. Thanks a lot.
Thank you, sir.
So once I get everything collected, I will share all these things on the chat so that you people also will benefit for the statistics class. So let's meet on Friday for probability. By the time you can have a look at the PPT sent to you also. So you can also tell me like what you understand by probability, even more than what I tell. Okay. Thank you.